Ever wondered how your email filters spam, or how your social media feed seems to know you so well? This is all thanks to machine learning. Machine learning, or ML, is a fascinating facet of artificial intelligence that allows computers to learn from data and make predictions or decisions without being explicitly programmed to do so. Now, how cool is that? In this intriguing world of ML, there are three major subcategories that form the backbone of most applications we see today: supervised learning, unsupervised learning, and reinforcement learning. Each of these categories offers a unique approach to teaching machines to understand, analyze, and predict outcomes based on data. From identifying spam emails and personalizing your newsfeed, to enabling self-driving cars and voice-enabled assistants, these subcategories of machine learning are silently shaping our digital lives. Now that we've piqued your curiosity, let's delve deeper into the first subcategory. Imagine teaching a child to identify animals. You show them pictures and label each one. This is quite similar to how supervised learning works in machine learning. Here's the rundown. In supervised learning, we have a labeled data set, which essentially means that the data comes with answers. It's like having a teacher supervising the learning process. The machine is presented with examples, inputs, and corresponding outputs. The goal is for the algorithm to learn from this training data and then apply this learned knowledge to new, unseen data. Consider a simple example of image recognition. Let's say we have a collection of images labeled as cat or dog. We feed these images into the machine learning algorithm, teaching it to recognize the features that distinguish a cat from a dog. After the training process, when we present a new image, the algorithm should be able to correctly identify whether it's a cat or a dog based on what it has learned. Another practical application is spam detection in emails. The machine learning algorithm is trained on a dataset of emails, each labeled as spam or not spam. The algorithm learns the patterns in the data that indicate spam, such as certain keywords, the sender's email address, or the email's format. Once trained, it can filter out spam from new incoming emails. The beauty of supervised learning is that it's straightforward and highly effective. It's used in a vast array of applications, from speech recognition and medical diagnosis to financial forecasting and beyond. Let's not forget though, supervised learning is not without its challenges. It requires a large amount of labeled data, and obtaining such data can be labor-intensive and expensive. Plus, it's only as good as the training data it's given. If the data is biased or flawed, the predictions will be too. Clearly, supervised learning is an essential cog in the machine learning wheel, but there's more to machine learning than just this. What if you have a ton of data but no labels? Enter unsupervised learning, the detective of machine learning. Imagine walking into a room filled with random objects and being asked to sort them out without any prior knowledge or instruction. What would you do? You'd probably start grouping similar objects together, right? That's exactly how unsupervised learning works. It's like a detective, sifting through mountains of data, looking for hidden patterns and relationships without any pre-existing labels or guidance. Now you might be wondering, where is unsupervised learning used? One of the most common applications is in customer segmentation. Companies often have vast amounts of data on their customers, but may not understand how they are interconnected. Unsupervised learning algorithms can sort through this data and group customers based on shared characteristics, helping businesses tailor their products and marketing campaigns to specific customer segments. Another powerful application of unsupervised learning is anomaly detection. This is widely used in fraud detection systems. By learning what normal transactions look like, these algorithms can identify and flag unusual patterns that may suggest fraudulent activity. But here's where it gets even more intriguing. Unsupervised learning isn't just for businesses. It's used in fields as diverse as astronomy, where it helps categorize galaxies, and in healthcare, where it aids in identifying patterns in patient data that could signal the onset of diseases. In essence, unsupervised learning is all about discovering the unknown. It's about finding hidden gems of insight in oceans of data, without having any preconceived notions or labels to guide the process. It's a powerful tool in the machine learning arsenal, one that's pushing the boundaries of what we can achieve with data. Aren't these applications mind-blowing? But hold on, we have one more subcategory to explore. Imagine training a dog to fetch a ball. This is pretty much how reinforcement learning operates in the world of machine learning. In the realm of machine learning, reinforcement learning stands out as a unique and compelling approach. It's like a game of trial and error, where the computer learns from its interactions with the environment, much like a child learning to walk. Each successful step is rewarded, each stumble provides valuable feedback, and over time the child learns to walk without falling. Reinforcement learning operates on a similar principle. It involves an agent, which is the learner or decision maker, and an environment, which is everything the agent interacts with. The agent makes decisions, takes actions, and the environment responds, providing feedback in the form of rewards or penalties. This feedback guides the agent as it navigates its way through a series of decisions. The goal? To find the optimal policy, which is a strategy that maximizes the total reward over time. It's like a game of chess, where each move is a decision that brings the player closer to, or further from, victory. Now you might be wondering, where is reinforcement learning applied? As it turns out, this approach has found its way into a myriad of applications. It's used in game playing, where artificial intelligence learns to master games from Go to poker. It's used in robotics, where machines learn to perform complex tasks, from handling fragile objects to navigating unfamiliar terrains. It's even used in web content recommendation, where systems learn to personalize recommendations based on user interaction. Reinforcement learning is also at the heart of some of the most impressive feats of artificial intelligence. Think of Google's AlphaGo, which stunned the world by defeating a world champion Go player. It used reinforcement learning to master the game, playing against itself millions of times, learning from each game, and improving its strategy. With these three subcategories, machine learning is indeed a game changer. But how does it fare in real-world scenarios? Let's not just talk theory. Machine learning is transforming industries and impacting our daily lives in ways we could never have imagined. Supervised learning, for instance, is the driving force behind many applications we use daily. Take email spam filters. These ingenious tools use supervised learning to determine which messages are genuine and which are unwanted spam. They do this by learning from labeled datasets where emails are marked as spam or not spam. Another example is voice recognition software like Siri and Google Assistant. These virtual assistants learn to understand our commands by being trained on vast amounts of labeled voice data. Unsupervised learning, although less obvious in our day-to-day activities, is equally impactful. Ever wondered how Netflix or Amazon seem to know exactly what you'd like to watch or buy next? That's the magic of customer segmentation, a result of unsupervised learning. These platforms analyze your browsing and purchasing behavior, grouping you with similar users to recommend products or movies you're likely to enjoy. Now, let's talk about reinforcement learning. This type of learning is all about learning through interaction and feedback. It's the genius behind the self-learning capabilities of AlphaGo, the computer program that shocked the world by defeating a world champion Go player. Reinforcement learning is also used in autonomous vehicles. These smart machines learn to navigate roads and traffic by continuously interacting with their environment and optimizing their actions based on feedback. And it doesn't stop there. Machine learning is being used to predict stock market trends, diagnose diseases, improve customer service, and even predict natural disasters. The potential applications are as diverse as they are fascinating. But what's truly exciting is that we're only scratching the surface. With advancements in technology and our growing understanding of these learning models, the possibilities for practical applications of machine learning are virtually limitless. Impressed? The world of machine learning is vast and ever-evolving, so keep exploring, keep learning. From spam detection to customer segmentation, from game playing to robotic control, machine learning is everywhere. It's an exciting world where algorithms learn and evolve, helping us make sense of vast data landscapes. We've delved deep into the realms of supervised learning, where the algorithm learns by example. We've explored the intriguing world of unsupervised learning, where algorithms detect patterns and relationships in data on their own. And we've stepped into the interactive sphere of reinforcement learning, where learning happens through feedback and interaction. These aren't just theoretical constructs. They're tools that are shaping our world, from the way we shop online to the way we control our smart homes. They're driving breakthroughs in fields as diverse as healthcare, finance, and entertainment. So, the next time you swipe through your music recommendations or marvel at a self-driving car, remember, it's all thanks to machine learning. Enjoyed the video? Hit that like button, share with your friends, and don't forget to subscribe for more fascinating insights into the world of tech.